Okay, for technology, natural science, and physics educators, I've got a circuit simulator on my website that you can check out. Some assessment defects look visual or technical, but they alter academic meaning of the task. So circuit diagrams are actually a good example. It is tempting to bold one reusable renderer and simply change the number of resistors, labels or switch states when you're doing a project like this. That works only until two circuits contain similar components but have different electrical topologies. Series, parallel, mixed and switch circuits require separate specifications. Every conductor must be traced. A valid circuit needs two source terminals, proper component interruptions, correctly shared parallel nodes, an integrated switch, a complete return path, and an unambiguous ownership of current, resistance and potential difference. If a renderer duplicates a conductor or places a switch outside the active path, the calculation that follows is compromised. Trust me, this is the hiccups I ran into when building this thing. The learner may reason correctly from the intended circuit and still be wrong according to the circuit shown. Separately, chemistry exposes the same problem through notation. Zn, or capital Z, lowercase n, and uppercase Z, uppercase n, are not interchangeable subscripts, charges, units, and exponents. That these things rather carry scientific meaning. So a generated test may contain the right calculation while creating unnecessary difficulty by forcing learners to maybe type in specialist notation, or scientific notation especially is an issue when doing digital answering. At that point, the interface begins assessing keyboard syntax instead of chemistry. So where possible, the interface should supply fixed units and scientific notation factors and ask only for the value the learner must determine. So format examples should use neutral synthetic values, never the real answer or suspiciously close clues. Rounding also needs one authority. A memorandum may use rounded intermediate value while the marking code retains the full precision. So both methods can appear reasonable, yet they produce inconsistent expected answers. So the assessment code, the answer key, memorandum, and tolerances and automated tests should therefore derive from one answer authority. Now that's, I think, the crux of this whole matter, and it relates to my previous talk. For financial calculations and stoichiometry, a reliable approach is to retain unrounded intermediate values and round only the final answer according to the declared convention. So the deeper point is that topology, typography, notation and rounding are not presentation details. They contain encoded meaning. When the visible artifact, answer authority and marking logic disagree, the learner is being assessed against multiple versions of the same question.